Okay, so 5.1, we're just going to take a look at some exponential functions, but let's take a look at some examples of these. To solve these problems, like if you remember from before when we first started talking about this, you need to make sure the bases are the same. So make these bases the same, I'm going to rewrite 9 as 3 squared. So that's actually like saying 3 squared, and then I put the x right there, equals 3 of the x. So I'm just only going to have to worry about the top. So it's 2x equals 8. I divide both sides by 2, and I get x equals 4 as my answer for that one. Need to make these bases the same. I understand you're looking at it saying, how do I make 4.5 the same? Well, here's what you can do. I can rewrite 4 as 1 over 2 to the negative 2. And you're saying, well, why? Well, 1 to the negative 2 is 1 over negative 2. And that's like saying 2 over negative 2. And you can't have negatives, so we flip them both. And that's like saying 4. So I can actually rewrite that as 1/2 to the negative 2. So which gives you now the same base if I write them that way. That'll end up giving us the same base. And let me just... There we go. So now I have it all fixed up there for us. So now that the bases are the same, I can just worry about the tops by setting them equal to each other and distribute that through, so I get negative 4x minus 2. Combine my x's together, so I got a 5x plus 2 equals negative 2. Minus 2 on both sides, so I get 5x equals negative 4, and divide both those to get a negative 4/5. So find the balance of the account if it is invested yearly, monthly, and daily. So if you invest $2,500 in an account with 3.6 annual interest rate for 10 years, then here's what you do. Yearly means 1, monthly means 12, daily means 365. So P is that, R is that, T is 10. So all this is, I know everything. So I plug that in for P. N is yearly is 1. The rate is 0.036 and T is 10, and we end up getting that. I need to change this. This is now 12 because it's now for monthly. And I'm getting 35, 81, 39, and daily is 365, and I end up getting 35, 83, 26. Your CD earns 11,000 compounded daily. So, find the amount of money that must be invested to have a final balance of 10,000. I want a final balance of 10,000 in 5 years. 10,000 is A, all right, because it's what I want to get. 11% is R. 5 years, that's T, and N, it says it's compounded daily, so it's 365. So I plug in everything, but I don't know P. So what I did was I got all this, and I took it to that power, and I got 1.733109406. So if I divide both sides by that huge decimal there, they'll cross out, so I'll get $5,769.98. If I put that amount in to the CD after 5 years, I'll get about $10,000. Find the amount of money that must be invested to have a final balance of 10,000 in 5 years. Your credit card charges 12% interest quarterly. So I want 10,000 again, but I know now it's 12% interest, so it's 0.12. It's compound quarterly, which is 4, and over 5 years. So same rule. I take that, I put it together on the calculator and take it to the 20th power. I get another big long decimal of 1.806111234. So I divide both sides by the huge decimals, and I get about $5,536.76 is what I'd have to put in to get 10,000. And once again, if I'm going really quick on these examples, please pause them, try them out, see what you get, and then unpause it and see if you got what I got. Okay? It's the best way to go through these. To graph this, you can try just plugging in the points, or like I told you before, just go to y equals, plug it in, and press second graph, and you'll get your list here. You'll get this big long list that I'm getting on your graph. You want to plug it all in yourself. So negative 3, 15.63 is way up here. Negative 2, 6.25. Negative 1, 2.5. 0, 1, 1.4, and 2, 0.16. And there's your graph. And notice how it should be decaying because it's a fraction. 2/5 is a fraction. So plug that in on your graphing calculator as well. And here's a list of some points that you'll get when you plug it in your graphing calculator. Once again, this fraction should be telling you that it's a decay, so it should be coming down this way. Just something to keep in mind. So notice how when negative 113 is there, 0, 8's there, 1, 5.5, 2, 4.25, 3, 3.63, 4, and 3.31. And remember, this number here is your horizontal asymptote. Notice how it's getting really close to number 3, but it won't ever touch it. That's what that number right there helps tell you. And this crazy one up here, just plug it in as a 3 caret sign, parentheses, 1 minus x squared, end parentheses. That all needs to be up in the air. And on your graphing calculator, get these. So negative 2 and a really low decimal, negative 1, 1, 0, 3. 1, 1, 2 with a real low decimal, and you end up getting a graph that looks like that. Determine the balance of an account with the interest compounded continuously. Continuously is e to the RT, so that's your rate, that's your time, that's how much you're putting in. So that's P, that's R, and that's T. The E button, remember, is second ln when you go to plug this all in, and you get 5,563.85. Determine the balance of an account with the interest compounded continuously of $12,000. So that's P, invested at a rate of 5.5, so that'll be 0.055, and your T is 5 when you plug it into this formula. And you know it's this formula again because it says compounded continuously. So I plug everything in. You just type it all in at one shot on the graphing calculator, and you get 15,798.37. Determine the balance of account with the interest compounded continuously. If you put $500 in, it was invested at 4% for 2.5 years. So that's P, that's R, 2.5 years, it's 2.5 that goes in there, 4%. Remember, you move it 1, 2 decimals to get 0.04. $500 you put in, so you'd make it would be $552.59. So you made $52.59 after 2.5 years. And when we come back here, I'll try to finish up with the rest of your examples.